Okay. Okay. So let's uh, welcome to today's training, and let's start. And today our topic is about CSP control mode. It's one control mode of under Ethercat protocol, and this is the most widely used control mode. First, I will introduce what's the introduce this control mode first, and some applications and the relative object dictionary. Then last, I will use 6V and use PDO to configure it to show you some relative object dictionary, how they works. This is the introduce about cyclist ignorance position modes. In these control modes, the upper controller PLC will calculate the position, the target position, and send the target position to the driver, and the driver will follow the command of the master and to move. So the position calculate is complete by controller, and the server just follow the command of controller to move. Because we say it is cyclic synchronous, so it means in every Ethercat communication cycle, the driver will update a new target position to the driver, and the driver will follow. And the next cycle, PLC will send another new target position, and follow, and the driver will follow again. Here I have two pictures show you the difference between the different synchronous cycle. You can see the smaller cycle synchronous cycle is, the more smooth our movement will be. For example, if we want to do the interpolation, circle interpolation, here with a smaller synchronous cycle, this circle will be more smooth. But here, just like this, is better here. And yes. And some applications about CSP modes. In fact, CSP modes are used in many applications. For example, in industrial robots and CNC machine. CNC machine also use CSP modes, and also some automatic production line, just like position control in VD2 series. And some relative objects dictionary of CSP mode. This part is more important. Okay, so from this picture, you can see for CSP control mode, we have this parameter, many parameter. We need to calculate and send it to driver. And this is the parameter. This is the object dictionary. The driver will feed back to the PLC. Yeah, it's PLC. Here is driver. You can see first we need to set the control mode of driver. So we need to operate this parameter, and also PLC need to set the target position to driver and the position offset and some other parameters. Okay, let's check it in details. First here, this object dictionary is used to set the control mode of our driver. As you can see here, for cyclic ignorance position mode, we need to set the value of this object dictionary as 8. And if you want to make the driver run in other modes, you can change parameter of this value of this parameter. And this table is from our VD3E menu. So for array, for all parameters, you can check the details in our menu. You can see here, RW means this parameter is supports read and write. And this means we can configure it in output PDO. If you remember in our last training, I have shown you there are two different type of PDO configuration. One group is input, and one group is output. Output means PLC sent parameter to driver. So this parameter is in output. So our PLC need to write value to this to change the operation mode of driver. And here, these two parameter is first one is target location or target position. This is this parameter. PLC will calculate this parameter in every cycle and send it to driver, and the driver will follow to this position. And here also we have a position offset. Here have a form. The server target position will be target position at this offset. And if you set this offset at 0, then PLC, for example, PLC sends target 10 to driver, and the driver will go to position 10. And normally we didn't set this offset. We just keep it as default value 0. And both these two are also read and write parameter. It supports read and write. And also this two is in output group. And another object dictionary. Okay. First one is throwing arrow window, and this is the throwing arrow actual value. You know, there will be for example, this is our target position, and this is our motor actual position. Because of the communication delay, there will be a position error between the target position and the actual position. Yes, it's normal because there must be some delays between command and the actual position. So this parameter is used to monitor the following arrow. For example, if we set this following arrow as 1000, and when the position arrow between actual position and the target position is bigger than 1000, then our driver will report this arrow 36. When will this arrow appear? For example, they have some question about the machine parts. For example, PLC is always sending the position command, but motor because of the machine code question didn't rotate or rotate very slow. In this situation, the following arrow will become bigger and bigger, so this arrow will appear. So uh, this is the limit we set for arrow 36, and this is actual value, actual following arrow. So when this one is smaller than our limit, it will be okay. But when the actual arrow is bigger than our target, than our limits, this arrow will appear. This is position arrive, position window, and the position window time. How to understand these two parameter? These two parameter is just how to say used to adjust whether the position is company is finished or not. For example, we set this value as 10, and then if the target position is 100, and when the motor position is between 90 and 110, when the actual position is in this range, the driver will sync. The driver will adjust that this position is finished. So bit 10 of this stator watts will turn on. This object is the status of our driver, and bit 10 we can check it. What's bit 10 of it? Okay, here this is 6040, and the bit 10 is, check. Oh, sorry, here this one is stator watts, and the bit 10 is here. Target arrival, and when it turned on means our motor have already achieved our target position. So this parameter is used to set the range, and this parameter is used to set the time. It means it set, for example, target position 10, and here the window we set as 10. Sorry, target position 100, and the window we set 10. So when the position of the motor is between 90 and 110, and the lasting time is bigger than this value. For example, here we set 1 second. In this situation, the bit 10 of this 6061 will turn on. Otherwise, it will turn off. Okay. And then later I will show you in program for these two parameter. Okay, continue. And here have also some other object dictionary. Example, position feedback, actual velocity, actual torque. And this parameter here, you can see this three parameter is its type is RO. RO means read only. Means read only. And here you can see also here data mapping. It is TPDO. It's different. These are RPDO, but these three are PDO. PDO means this is we need to put it in inputs input group of PDO operation because this parameter is come from driver and come from driver to PLC. So the direction is different. Okay, so now I will open the software to show it. First, we can check the PDO of PDO configuration. First, for this RPDO, RPDO is here. These are RPDO, RPDO, RPDO. Here I have add some object here. For example, this position offset and the position window time. This three is not in our default PDO group. I add it here. And also for this group, I also add some parameter. For example, this flowing arrow actual value and the velocity actual value. And also I have already mapped this parameter, map this object dictionary to our variable that, already. In our last training, I have already shown you how to add how to change the PDO configuration and how to map it to our variable. Okay. So now let's compile and download the program. Okay, now let's check the some function block. First is this one MC power. MC power is is used to enable the driver. For VD2 series, we also need to enable the driver by DI signal to enable it. But for VD3, we use this function block and use communication to enable the driver. And these two parameter is rate position and the rate velocity. So you can see here, this is the position and this is the velocity. And also this function block is used to read the status of our driver. Here I have many status of driver. for now is standstill. Standstill means is uh, keep no movement. And when it is for example, when you use MC home instruction to do the homing, the status will change to this one. And if you use MC stop to stop the axis, you will see the driver status will change to this stopping, and also disable and stop and so on. Okay, I'll repeat once. Okay. First, this one is used to enable the driver, and this two is used to read the position and read the velocity of our driver. And this function block MC read status is used to read the status of our driver. And here you can see here have many outputs of this function block. And for now you can see from this video, you can see the axis is stop here. So it's standstill status. And now, for example, I move it by this MC jog function block. Now axis, the motor begin to rotate, and you will see here the status of our driver is changed to this continue motion. Continue motion means is continue move. And now I stop it. You will see the status will change back to this standstill. Okay, here, standstill. And this two function block is used for move absolute move and relative move. Here we have position, velocity, acceleration, deceleration. What I want to say is, for example, because this function block, we only need to set the movement parameter. For example, the target position 10, and after our setting, the PLC will write parameter 10 to this object. For example, to calculate the position and send to this this object dictionary of our driver. Also MC stop. Here we have a monitoring variable. Here right click, you can add this variable to our window here. Okay, now let's check this table. First is actual position. Actual position is you can see in PDO. Actual position is this parameter, and this parameter we map it to 6064 this object dictionary, and this object dictionary is our position actual value. So here, if I move the motor, you can see the position will change, and then go back because it's enabled, so I can't move it. And this is our target position. You can see target position will not change because we didn't change our target position. Now we use let's use this move absolutes and set the target position as 0. And then we can And let's run it and check here. You can see here the target position is always changing because in every synchronous cycle, the PLC will give a new target position to driver, and this is the actual position. It will follow this parameter, follow it, and the last stop at 0. Okay, it's normal to have a little error because the axis will move. How to say? Will have a little shock or something. So the position will change, will keep changing. But this change is very small because this is 17. This is a 17 motor, 17 encoder. So for one side, for one circle, is this 131,000, and here only have one arrow. So you can see it's very small angle, about sorry. Okay, so this is the angle. The angle changed here. Only is very small. So we can see it's almost no almost stand still. And now you can see his flowing arrow window. We can flowing arrow window here. This variable, I map it to 60F4. 60F4 is the offset. Oh, let's check this one. Position offset. Position offset is here. I map it to 60B0. As we said here, for now it's 0. So we can see the target position and the actual position is almost same. And now let's set this offset as, for example, 100. You can see the actual position will change. You can check this axis video. Here will show when I change it to 1000, you can see the motor will move a little angle. Did you see it? Maybe 2000. It's move a little. Could you see the position change of axis here? Thousand, then it will move a little in this direction. Okay. Now let's check another. Let's go to, for example, 40 position. Okay. So now here, this one is our follow arrow actual value. It's about 5,000, and this value is always when the movement is finished, this arrow will this arrow is changed to about 0 because our target position and actual position is same now. Let's go back to 0 again. Let's set it as this value. Okay. And this is actual torque. This is percent, 100%. The unit is 0.1 percent, 100%. So this is about uh, this value. This is 2% 2% 100% of our relative torque. Position is arrive our target position now. And also here, you can see this position achieved. This variable, I map it to position. Oh, here, sorry. I map this bool. I make this bool variable to bit 10 of 6061. And as we said, bit 10 of this object dictionary is target arrived. And when it is turned on, it means our motor have already achieved the target position. So it's always changing between on and off because here the actual position is changing. And here, if we set the position window as, for example, as 10, you will see this bit will always on because the arrow between the actual position and the target position is always smaller than 10. So the driver will think will thought that these two value these two parameter is same. And also here have a window time. Window time here. Unit the unit is window time is ms. Let's change it to, for example, $1,000. Okay, now let's change it to 0, 10. Well, you will see here. Let's try it again. You will see after we change the this position window to 10, this bit will turn on after 1 second. 1 second, and it turn on. And if we set this as, for example, 5,000, 5 seconds. Here, when we set this as 10, you will see after 5 seconds, the bit 10 of stator watts will turn on. So this is how this two parameter works. One is used to change the limit, change the range, and another is used to change the time. Achieve an actual torque. following arrow. Okay, and this is some mainly objects dictionary in CSP mode. Uh, but some people will ask, for example, do we have to configure this PDO every time when we use CSP modes? I would say it depends on the controller. For example, for our 6C or 6V controller, they have already some built-in function block. So we just need to use this function block to enable to control to move our driver, and we don't need to do this PDO mapping because uh, because this function block is just include this function is already include this PDO setting or PDO communication configured inside. So we just need to set the position, velocity, and run it. And the PLC itself will calculate the parameter of this object and send it to our driver. But some controller, for example, not PLC, just EtherCAT master. So we have to configure this parameter and configure use PDO to change the value of PDO to enable our driver and change the target position or change the operation mode to change to for our driver. Okay, and the last here also have a dual in function block, so I can also show you how it works. Here we have two axes. Axis 0 is our EtherCAT axis, is this motor. And this is EtherCAT axis. And another axis is, let's check. Another axis is local post axis. So axis 1 is use our PLC output here. Here PLC outputs, input outputs. Use PLC Y terminal to send pulse. And now set on this M0. Okay. And now, for now, I can directly jog our pulse. You see the motor here. When I jog our axis 1, you will see motor is also rotating because here we use this dual in function block to make a dual ratio between our pulse axis and our this is our EtherCAT axis, and the dual ratio is 1.1. So here, the jog speed of our pulse is also is also the speed of our EtherCAT axis. Now let's change this ratio to 2:1 and the dual in again. Jog again. You will see the speed of our EtherCAT axis is about 4 because our dual ratio is 2 now. Okay, and they also have other function block in CSP control mode. Many some other function block, but here I have no time to introduce them one by one. So this is our today's content about CSP control of VD3 driver, especially this related object dictionary, how to use it, how to configure it, and how it works. Okay, thanks for your attending. Do you have any questions? Okay. If we have any questions, we can also discuss in our training group. I will reply as soon as possible. Okay, thanks for your attending. And our today's training is finished. And I will also share the video replay in our group later.